So here we have the integral of sine of 2x multiplied by e to the cosine of 2x with respect to x. Now obviously you get a little worried when you see the trig start popping into things, but it's okay because if you look and notice that your exponent of your e is a trig function, that means we're also going to have to sacrifice a trig function in order to integrate it. So let's see if we can kind of pick it apart and go from there. I'm going to bring the e to the cosine of 2x to the front because I think that that's going to be my main function. So I'm going to think of that as e to the u. Then I'm going to put the sine of 2x back here with my dx because that's hopefully going to be a portion of my du if all goes well. Now, what is the derivative of cosine of 2x?
Negative sine.
Negative sine of 2x multiplied by 2 because you have to give away the derivative of the angle as well. So we need a negative to balance it, and we need a 2. If we do that, this is the derivative of my u. So this is my du, and that will become my sacrifice.
Excuse the interruption. We need you.
So anyway, that will be our sacrifice right there. But if I do that, I need to balance it with a negative 1/2 to undo the negative 2 that I inserted. So this is my du. I'm going to integrate e to any power. It will just be its own exponent as long as I sacrifice the derivative of the power. So we'll bring down the coefficient of negative 1/2, and we will bring down the e to the cosine of 2x plus c. And that looks a little crazy, but if you check it, if you take the derivative of that, it actually does go back to the original function. This is our next to the last example. We have the integral from 0 to 1 of e to the x over 1 plus e to the x dx. And anytime you have a binomial denominator, you have to remember that you bring it up as one entire parentheses. So when it comes to the top, the whole thing comes to the negative 1 power. Right, guys?
Yep.
All right, now, we either need to distribute and get rid of those parentheses, or I'm going to have to treat it like a parentheses to a power and sacrifice the derivative of the inside. Can I distribute it?
No.
Why?
Because it's negative 1 power.
Because it has a power on the outside other than 1. So you're not allowed to distribute. So our hope is that we are able to give away the derivative of the inside.
Yeah.
What is the derivative of the inside? Well, that's perfect. It's like a perfect trade. I will keep the 1 plus e to the x to the negative 1 power. I will give away the e to the x as the du, right?
And so that becomes ln.
Yes. See, if I give this away, technically, in a normal situation, that would allow me to do the power rule. But with a negative 1 power on a parentheses, it doesn't utilize the power rule. We have to know that that becomes the natural log. Yeah, so that's the trick. So this is going to become the natural log of 1 plus e to the x because of the negative 1 power. Now, if it were negative 2 power, we would add 1 to the power divided by the new power. But just because it was that negative 1 power, that power would zero out, and that's our cue that it becomes a natural log. Now, someone tell me, do we need absolute value on that?
Yes. Yes.
I say no.
I think yes.
Oh, we're split. So someone argue. If we don't need it, that means that there's no way it could be.
Negative.
So you tell me, regardless of what x is this always going to be positive?
No.
Okay, what's e stand for?
We don't know.
2.71828. E is 2.7 something, right? So we agree e is positive. Take a positive number and add it to a positive number to any power. A positive number to any power will stay, even if it's a negative power. It'll become a decimal, but it'll stay positive, right? Okay, so this is going to be a positive plus a positive, so we don't need absolute value. If you put them there, it would be okay. I wouldn't be upset. It would just be redundant. So we technically don't need them there. And we're going to integrate from 0 to 1. So that just means we're going to substitute in 1. So we have the natural log of 1 plus e to the 1 minus the natural log of 1 plus e to the 0. What's e to the 0?
1.
So 1 plus 1 is
2.
2. So here's one possible answer. The natural log of 1 plus e minus the natural log of 2. A lot of times you're going to see it written this way. Natural log shared of 1 plus e all over 2. Simply because 2 natural logs subtracted become a single natural log of the 2 things divided.
Okay.
Okay guys, final example. We have the integral of e to the x multiplied by cosine of e to the x with respect to x. So do we all agree that e to the x is acting as the angle of the trig function?
Yes.
So if we want to integrate cosine of anything, we'll just even pretend it's u. I have to first give away the derivative of the angle. Well, the derivative of the angle is
E to the x.
e to the x. So this is my du. So I can sacrifice that, don't have to balance it, don't have to make anything up. And then I can pretend that this is just a plain x. And the integral of cosine is,
Negative sign.
well, the derivative of cosine is negative sign.
Positive sign.
The integral is the opposite. The integral of cosine is positive sign, but you keep the angle. And I don't know why the parentheses are there. They're technically not needed, but I'll put them there because they were there originally. And if you take the derivative of that, you'll see that you get cosine of e to the x times e to the x. And that wraps up section 5.4.